Welcome back, everyone. In this video, we're going to be talking about the Pythagorean Theorem, which I'm sure is probably one of the only things that you remember from high school. I know that's one of the only things I remember from high school math a lot is, oh, the Pythagorean Theorem, a squared plus b squared equals c squared. If we break it down a little bit more, it only applies to right triangles, and that is any triangle that has a 90-degree angle in it. That's usually noted by that little box that you see there that denotes the 90-degree angle side. There's three sides to every triangle. There's three sides here, A, B, and C. A and B are both called legs or just sides of the triangle. C is always reserved for the hypotenuse, at least in terms of Pythagorean theorem. It's the longest side of the triangle, and it's always going to be the side that's across from the 90-degree angle. If you see here, we have it. This 90-degree angle is across from it. Is across from this side, the hypotenuse. And you can use this theorem, which the proof is very advanced. It was done a really long time ago, to prove this. But just kind of take it as fact now. The mathematicians before us did all the hard work for us in proving it. Now it works. We can use it to our advantage. Now that we know for any right triangle, the squares of both legs is equal to the square of the hypotenuse, we can use it to solve some things about these triangles, and solve for missing sides. And also evaluate whether or not a triangle will be a right triangle based on the values we know. So we can check all this stuff out. And we're going to do that now. So without any further ado, we have a true or false question. It says a triangle with sides 7.5, 10, and 12.5 units, respectively, is a right triangle. Well, why don't we evaluate that? We have a thing for that now. We have a theorem for that. So what we know is that, and it's important to keep in mind here too, the longest side always has to be C. It will always be C. That's what it's denoted as when you're using the theorem. So we have to make this value C, and then A and B can interchange between either one. I'll just say B is 10. And I'm sorry, I should switch these colors around just to stay consistent. Okay, so C will be 12.5, B will be 10, and A will be 7.5. Okay, so now what we need to do is use Pythagorean theorem. A squared plus b squared equals c squared. Well, we have then that 7.5 squared plus 10 squared, and we have to see, does this equal 12.5 squared? Okay, well, let's just, see what this is. 7.5 times 7.5 is 56.25. We know that 10 squared is 100. We want to know, is that equal to 12.5 squared, which is 156.25, which it is, because we can see that 56.25 plus 100 is in fact 156.25. So this checks out, and this is true. All right, so that would be it. And they'd call that a Pythagorean triple. It's three numbers that satisfy the theorem, the relationship in the theorem that a squared plus b squared equals c squared. The sum of the squares of the two shorter sides is always going to be, is going to be equal to the length of the hypotenuse. That's what the theorem states. Okay, so if a right triangle has legs, as we called before, the two shorter sides, with lengths of 18 and 24, find the hypotenuse. Okay, so we know that we can use the Pythagorean theorem for this too. We can add the squares of the legs together, which would be 18 squared plus 24 squared. And that should equal the length of the hypotenuse, which is C, and it should equal the square of the length of the hypotenuse. So 18 squared is 324. 24 squared is 576. And that should be equal to the length of the hypotenuse squared. Okay, so we know here 324 plus 576 is 900. It's equal to C squared. So now we just take the square root. And the square root of 900 is plus or minus 30. But since we're dealing with lengths, you can't have negative length. It's just impossible. So we only consider the positive value, which is 30. So C equals 30. That's the length of the hypotenuse. And that's what they asked us to find. So we're done now with that problem. Okay, so in the following right triangle, right triangle, this only works with right triangles. So you can't use this theorem on any old triangle. It has to be right triangle. In the following right triangle, if B is 11 and the hypotenuse is 18, find A. So we're going to do relatively the same thing we just did before. The only thing that changed is that they neglected to give us A instead of the hypotenuse. So we know that B is 11 and C, or the hypotenuse, is 18. So what we have now, we don't know what A is, so we just have A squared plus B squared, which would be 11 squared, is equal to 18 squared, because C is equal to 18. Okay, so now we have A squared, 11 squared is 121. 18 squared is 324. Okay, so now we are going to solve for A, we're going to subtract 121 from both sides. So we have A squared is equal to 203. Now it says round to the nearest hundredth. I mean, we know that that 203 isn't a perfect square, so we're going to get some kind of like ugly decimal filled answer. So we take the square root on both sides. So A is approximately equal to, because we have to round, so it's important to note that it's not going to be the exact answer, it's just going to be approximate if we do round. Which, if we rounded to the nearest hundredth, you get 14.247. So that 7 would mean that we have to round up. So we'd end up with 14.25. And that would be our final answer. We solve for what they asked for. We solve for the rounded value of A. Okay, the next one doesn't necessarily have to do with the Pythagorean theorem, just natural laws of triangles. Triangles, the angles inside always add up to 180 degrees. So we can tell a few things right off the bat here. We can tell that that this will not be, or this may or may not be a right triangle. We don't know for sure. We don't have that as a given. All we know is we have some triangle. I don't know if that was the right shape. No, it was not. We have some triangle. It might not look like that. It's probably not going to be equilateral, but it's just for the sake of demonstration, this is not to scale, but one side's 82 degree, or one angle's 82 degrees, one angle's 46 degrees. And we don't know this one. It's a question, or that's what they're leaving us to solve. But we do know that the sum of all the angles is 180. So if we take 46 plus 82, excuse me, and we call this unknown angle X, we know that has to equal 180 degrees. So 46 plus 80, oops, excuse me. One more time, 46 plus 82 is 128. And then all we have to do to solve x is subtract 128 from 180. So our missing angle is 52 degrees. This one's not a right triangle, then that's just solved. The only thing we needed for this was to know that the internal angles of any triangle, right triangle or not right triangle, will add up to 180 degrees. And then we can use that to solve. And that would be the end for this one. Hope this helped, and I will talk to you all next time.